Okay, everyone, in section 5.6, we are going to talk about the fundamental theorem of algebra, which sounds very foundational, fundamental theorem. Basically, it's how many real zeros different equations have. For instance, if you have a linear equation, unless it's horizontal, it's going to have one real zero. It's going to go through the x-axis at one point, and that's fine. But look at a quadratic. If we have a quadratic, we could have two real zeros, two solutions, or we could have just one real zero like that, or it could be over here that it has no real zeros at all, never touches the x-axis at all. So how do you deal with how many solutions or how many zeros these kind of different polynomials have? Well, that's what's called the fundamental theorem of algebra, and I've already hinted at it quite a bit earlier in previous videos. But basically, the fundamental theorem of algebra says that the number of roots, maybe not the number of zeros, not real zeros, but the number of roots is equal to the highest degree, the degree of the polynomial. And even this one, because this one would have two imaginary roots, wouldn't it? So you have to take into account repeated zeros and imaginary zeros. If you include repeated and if you include imaginary, you will always have the exact same number of roots as the degree of the polynomial. Even in this one, you have only one zero, but you have that twice. This is just an x squared or an x minus 0 squared, so you have 0 twice. So it's in that one, you still have two solutions. So here's an example of a fifth degree polynomial, and because it is fifth degree, we know we're going to have 5 roots, and our job is to find all 5, which sounds intimidating, but I'm going to show you that it's really not as bad as you might think. So step number 1 is set up your synthetic division box for this polynomial. Okay, so here's my synthetic division box, and now I'm going to just try numbers, but I know from last section which ones to try. I'm not going to just try any numbers. I'm going to try factors of 4 over 1. So positive and negative, 1, 2, and 4. Those are my only ones that I need to try. That helps a lot. So let's start with 1. So let me whip through. Here it is when I'm trying the root of 1. So this is 1, 0, 0, negative 3, negative 3, 0, 0, negative 4, negative 4, 0, and I found my first one already. That's nice. I'm going to circle my 1 because I know that's one of my zeros. Now, if this was x to the 5th, this represents x to the 4th. I still have some more to go, so what I'm going to do then is just leave these numbers right where they are and draw another division box. Now, it's possible that 1 could be a 0 with a multiplicity of 2. It might work again, but I'm going to go ahead and try negative 1 anyway. Then if all of them don't work, I'll go back and see if there's any duplicates. But I'm going to go ahead and try negative 1. So let's try that, see what happens. So this is negative 1, negative 1, 1, negative 2, 2, 2, negative 2, negative 1 didn't work. So now I'll try 2. Here we go. 2, 2, 4, 1, 2, 2, 4. Nice. It worked. 2 is another root. So I found 2 of them. So if this is x to the 5th, this is x to the 4th, this is x to the 3rd degree. I'm not done. I need to get down to x squared, then I can use the quadratic formula for the last 2. So I still need to find one more using this strategy. So far I've tried 1, negative 1, and 2. Next is negative 2, so I'll try negative 2. And here we go. So negative 2, 0, 0, 1, negative 2. Nice. I got lucky. Okay, I have found 3 roots. 1, 2, and negative 2. This is x to the 5th, x to the 4th, x cubed. This is finally x squared. So this is x squared plus 1. That's what this represents because I had 0x, x squared plus 1. So hopefully you remember when you have the sum of two squares, this pattern is x plus I, x minus I. I don't know if you remember that or not. If you do, it's really helpful. If you don't, the quadratic formula will get you there, right? This b is 0 when you do it though. So a is 1, b is 0, c is 1, and this is what you'll end up with when you do that. So my 5 roots then are 1, 2, -2, and positive and negative I. There are my 5 roots. Here's the next one. This is the got it question in your book, and I'm just going to go ahead and walk through this because it has some different elements to it. It asks, what are all the roots of this polynomial? Notice it's a 4th degree, so by the time we're done, there should be 4 roots to this. We can't find them yet because it's not set equal to 0. It's not in standard form. So step number 1, put it in standard form. Okay, so now I have set it equal to 0. I moved these across the other side, and I have this. Notice if I'm looking for factors of my constant, it looks like it has no constant. But really, if you notice, all 4 of these terms have something, a common factor that I can factor out first. So by all means, factor out the x. Okay, I factored out the x, and now I just have a cubic left with a constant of 10. So that means when I try to find my real zeros or roots, I'm going to use just factors, numbers that'll go into 10 evenly. So this is what I'm going to use to set up my division box for my synthetic division. And I always like to start with 1, just for whatever reason, it just makes sense. So 1 times 1 is 1, add, that's 3, this is 3, this is -10. Oh my goodness, did I get lucky or what? Okay, I found one right away. A root is, or a 0 is positive 1. That's excellent. This was x cubed. That means this is x squared. So this means this is x squared plus 3x minus 10. Can I factor that? X plus 5, x minus 2? It looks like it. So this factors to be x plus 5, x minus 2 equals 0, which means my other 2 zeros are positive 2 and -5. Now you may think, wait a minute, okay, so here's 2, here's -5, there they are. You may think, well, wait a minute, I only found 3, there's supposed to be 4. The 4th one is right here. This is my 4th one, that I factored out. This is the same as x minus 0. This one is 0. So when you have an x like that that's out by itself, that one is 0. So my 4 roots are 0, 1, 2, and -5. There we go. Okay, with this next one, I want to show you a really handy trick that will help those of you who have graphing calculators, and it has to be a graphing calculator. A scientific calculator won't help you in this case. But this is our function. It's a 4th degree, which means it has 4 roots, and I want you to find them all. Now we're going to look for factors of 18, and there are quite a few. 1, 2, 3, 6, 9, 18, positive and negative. There's be a lot to check for to get down to x squared. And I'm going to show you that what you can do if you have a graphing calculator is put this in your graphing calculator, this function. So check your y equals, click on your y equals, and then enter in this equation and then select graph. Now what you will get is a picture of what the graph looks like. If you have your textbook, you can see what it would look like. What that does is it gives you what the real zeros are. Look at where it crosses the x-axis, and so you know which ones to check. Negative or positive, is it 3 or is it 6? That type of thing, so that you're not hunting and pecking so much. When you enter this one in a graphing calculator, you will see that it intersects the x-axis at -3, and positive 3. So we found 2 of them. So here's what you can do then to find the other 2. Okay, now that I've looked at my graph and I see that 3 and negative 3 are where it crosses the x-axis on the graph in the graphing calculator, now I don't have to hunt and peck for my first zeros. I can just set up my synthetic division box and use 3 and negative 3 as zeros to divide down to get from a 4th degree down to a 2nd degree polynomial where I'll be able to use the quadratic formula. So here's my synthetic division box, and I'm going to go ahead and try 3 and show you how quick, relatively quick this is. So this is 3, this is 4, 12, 5, 15, 6, 18, 0. So this represented x to the 4th, this represents x to the power of 3. So I'm going to draw another one, and now I've used my positive 3. Now I'll use my negative 3 and go through the same process. So this is negative 3, 1, negative 3, 2, negative 6, 0. Awesome. 4th degree, 3rd degree. This is my 2nd degree, which means x squared plus x plus 2 equals 0. And there are not factors of positive 2 that add up to positive 1, so I have to use my quadratic formula to find the last 2. I'm going to go ahead and walk through that too, just to help you out a little bit. I'll erase this just to give me room. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2. Now I simplify. This is 1 minus 8 or negative 7. So what we have is negative 1 plus or minus I square root of 7 over 2. This is 2 of my zeros. So all my roots are plus, positive and negative 3, and this, negative 1 plus I square root of 7 over 2, and negative 1 minus I square root of 7 over 2. This is fine with me in this form for quizzes and tests. Check online when you're doing online what form they want for this equation. They might want it in standard form, negative 1/2 plus square root of 7 over 2i, and negative 1/2 minus square root of 7 over 2i. They might want it like that. I don't know. So just double check. It could be in either form. And that's how to do it when you use a graphing calculator to help you start with the real zeros so you're not hunting and pecking for those first ones. Okay, your lesson check for this lesson is to find all the zeros of this 4th degree polynomial of this function. Be careful when you set up your synthetic division. Notice you're going to need placeholder for x squared. This is 2x to the 4th minus 3x cubed minus x minus 6 is this function. It is your got it question number 2 in your textbook, just in case I copied it down wrong. And bring that in for your lesson check, and that's it for this one. Have fun with this. It's not as bad as some of the others. So I will see you guys next time. Bye for now.